Okay, we're going to be talking about vectors and vector components in this. And vectors are really important. Well, in math, they're important, but they're particularly important in physics. Um, what a vector gives you two pieces of information. It gives you a magnitude or size, and it gives you direction. We've already looked in physics about the difference between velocity and speed, where velocity has direction and speed does not. And many things that we're going to be looking at in physics, such as forces or torques, all the direction in which they are being applied are extremely important. So that's why we need to start introducing the idea of vectors. So for example, you could say that there is a force of 10 newtons. Um, well, in what direction? Let's say 50 degrees above the horizontal. So what a vector does is it represents both the magnitude and the direction. So I have a compass here. So we have this. Here's our horizontal right here. Oops, that's not what we want to do. We've got our horizontal right here. Maybe I can't write over the compass. So here I've got my 50-degree angle right there. Let me pause this for a sec. Okay, so the compass was a great idea, but Smartboard doesn't let you draw on it. So again, we've got this 50-degree angle that we had just drawn. And so what we do is we say, let's consider this to be 10 Newton force, and it's at an angle here of 50 degrees. So again, a vector which we represent by being this arrow. So it has a starting position right here. It starts with a little, maybe a circle, and it's just an arrow pointing in the direction of the force, and it represents both magnitude and direction. Okay, so let's think about a vector. So John walks. So let's start here. Here's John at the very beginning. He walks 3 units east, so 1, 2, 3, and then 2 units north, 1, 2. So this vector represents John's displacement after his first walk. Then he walks 4 units west, so here he is here, and he goes 1, 2, 3, 4 west, and 1 unit south, and here he is after that. So this blue vector represents his displacement after his second walk. Well, where is he in relation to his starting point? So in relation to his starting point, he is just 1 unit north and 1 unit west. So this black line, that black vector, is the sum of the two vectors. So when you want to add vectors, you just draw one vector and then start the new vector at the end of the old vector. And we call this adding vectors tip to tail. So let's say I have some black vector here and that has some magnitude and direction, and some green vector here. If I wanted to add those, what I do is I have some starting point, and there's my black vector. And then I want to move my green vector and add it tip to tail. And so my resultant vector, the sum of these two vectors, is this starting at the end of the first, or the tip of the first one, and going out to the arrow of the last one. And so this tells me the sum of the magnitudes and directions. So the sum of the two vectors. Okay, well let's see this in action. So the first thing that we need to do is develop some mathematical understandings of these vectors. So just like in Algebra 1 and Algebra 2, we had a bunch of important laws. We're going to look at those same laws. And the first one that we're going to look at is the commutative law. So let's look at what happens. Let's say that we're starting with vectors a and b, and so I have vectors a and b over here, and vectors a and b over here. So what if I were to go like this? What sum is that looking at? I'm starting with this black vector a, and b is starting here. So red is looking at some sum. My c vector is some sum. And what is it? Well, c equals a plus b. And we represent vectors with a little line over the top. Okay, so I'm adding a to b, and I get that red vector c. This being the same vector here. Well, what if instead of going a plus b, what if I had done b plus a? So now b is the first vector and a is the second. Well, let's think. What's the sum of that going to be? If I put in here, I get that this value here, which is b plus a, also equals vector c. So what does that tell us? Well, that's the commutative law. What we just showed is that a plus b, vector a plus vector b equals vector b plus vector a. It's a nice little graphical demonstration of the commutative law. But what about some other laws? How about the associative law? So here we have the associative law, vector a plus b in parentheses plus c, and we want to show that that equals a plus the sum of b plus c. So let's look at this right here. So we've got vector a being added to vector b. That's vector b there. So we have a and b, and this yellow vector would therefore be a plus b. And my green vector right here, well, we've got my blue vector b being added to my red vector c. So therefore, this vector here is b plus c, which we'll call b plus c. Okay, so this is to develop this idea. If we look over at our starting situation on the left-hand side, we've got my yellow vector. I don't want to get rid of its color, so let's do this. Yeah, that's good. So we've got my yellow vector here, which is a plus b, being added to c. And so we end up with that net vector, which is a plus b plus c. Well, similarly, we could look at the green vector here. And the green vector is b plus c. And if we look, we have a plus b plus c, and the resulting vector is exactly the same as before. It's this line here. So that shows that we have the following identity, or law rather, the associative law, holds for vectors as well. So it doesn't matter in which way whether you add a plus b first and add it to c, or do b plus c first and add it to a. Either way you associate it, you'll get the same answer. What about subtraction? So when we deal with subtraction, what we want to do, and this is the same as algebra, we want to treat subtraction like adding a negative. So the question then is, what is a negative vector? Well, remember, a negative vector is just in the opposite direction. The negative sign just means opposite direction. So negative b is this vector right here. That vector there is negative b. So what we want to do is a plus negative b. There it is. There we are adding a plus negative b. And the result is, this vector right here. A minus b, or a plus negative b. So the key thing there is just when we're talking about subtracting vectors, what we mean is add the negative vector, where a negative vector is just a vector that's equal but in the opposite direction. All right, so let's look at an important idea, which is breaking vectors into components. So we've talked about the idea that vectors can be added to each other, and we've shown how that works geometrically. We've talked about the idea that vector is just some magnitude in some direction. But what's really important in physics is to be able to break a vector into its x component and to its y component. So let's imagine some vector that's 10 centimeters long at a 30-degree angle. So just to convince you of this ruler is set at a 30-degree angle. So you can see that it's 30 degrees. So let's draw this 10 centimeter vector that's at a 30-degree angle. So if we do that, it's at a 30-degree angle already, so we're drawing I think that's 10 there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Went a little bit over. Okay, so there we have our 10 centimeter vector, and it's at a 30-degree angle. But what we want to do is we want to say, okay, well, if we consider this vector A, we could break it up into its x component, and that's its direction in the x. And we write that as a sub x, and its component in the y, and we'll write that as a sub y. So a sub x means the vector a that's in the x direction, and a sub y means the vector a in the y direction. Okay, well, we know enough about trig already that we can sort of jump to some really big conclusions. This is a 30-degree angle. So what will a sub x be? What is this value? Well, that's just a cos 30. And a sub y is just a sine 30. And in fact, we should, let's get rid of this vector here, the sign, because we're implying the direction is in the x direction and the y direction. So what we're really just looking at is the magnitude of A, the size of A. In this case, the magnitude of A is 10 centimeters, and the way we represent magnitude is we do this absolute value sign of A, which says, let's just talk about its sign. And not like sine or cosine, but let's just talk about how much there is there. So there we have breaking up a vector into its x component and its y component. And this will be critical when we start talking about projectile motion where things that operate in the y direction behave significantly different than things that are moving in the x direction due to gravity, of course. Okay, so we can break vectors into its components. And let's think about some important identities that come out of that. Well, let's think about some vector here. Here's some vector A, and this green value is A sub x, which is the magnitude of A times cos theta, where this value is theta. And then we've got A sub y, which is the magnitude of A sine theta. And so what's true about A sub y over A sub x? Well, if we think about this just really quickly and do a little bit of substitution, A sub y over A sub x equals the magnitude of A sine theta over the magnitude of A cos theta. And we can see pretty simply that magnitudes cancel off, and what we're left with is tangent theta. So tangent theta, tan theta, is the relationship between A sub y over A sub x. So let's look at just one example problem, and that'll be it. I think you have enough ideas now to wrestle with some problems. So what we have is a dog runs away at an angle of 40 degrees east of north. So first of all, these problems can be a little bit tricky when we're talking about what direction we mean. So we'll come to this in a second. It says find its position coordinates, meaning find the components when the dog is 350 meters away. So let's think. We've got, here's east, here's north, and it says that it's 40 degrees east of north. So the of north is a critical is the critical piece of this. Of north means that we're starting at north, and then we're looking 40 degrees to the east. So we're going to open up 40 degrees in that direction. So in that case, this angle is 40 degrees. And we know that the length of this vector is 350. So this value here is 350. Well, just to be, I think to make it easier, let's create this triangle right here. We've got A sub x and A sub y. But since we've created this triangle, the angle that really matters now is this one in here, which is 50 degrees. So if the dog runs away at an angle of 40 degrees east of north, its position coordinates when the dog is 350 meters away, well, our position in the x direction is just going to be 350 cos of 50. And in the y direction, 350 sine of 50. And I think that's all we're going to say about vectors for the time being. So the key ideas from this: vectors have magnitude and direction. Geometrically, you add them tip to tail. The commutative and associative laws exist and are true for vectors. And it's important for us to be able to break them up into their components.